Maths is awesome, maths is fun, maths is there for everyone.
Welcome back to our next class, chapter 7. Today we're going to introduce the concept of congruent triangles. Now, this topic is something that's often really poorly answered because people don't understand the terms. Really important that you understand the terms and how we label things when we're comparing triangles that are congruent. Well, we know what a triangle is. It's a shape with three sides and three angles. But what does the word congruent mean? Well, if we're talking about congruent triangles, we mean they are absolutely identical triangles. So if I did this, and this side was 5, and this side was 5, and this side was 1, and I did this, and that was 5, and that was 5, and that was 1, those triangles are congruent. They are identical. One triangle is just the other triangle. It's just spun around, but their sizes are exactly the same and the shape is exactly the same. And because the size and the shape, because they're exactly the same, they also have angles inside that match up with each other. They're exactly the same. Now, this is important language that we're talking about now. Matching sides. Sometimes we call them corresponding sides. Matching sides will be the same length. For example, if I look at the triangles that I drew, this side here and this side here are the sides that match with each other or that correspond with each other. So they are the same length. Now, this side here could match up, doesn't really matter which side, because I could actually turn a triangle upside down, flip it, so I could say it matches with this side. And that would mean that this one matches with that side. So each one of the sides have a matching side from one triangle to the other triangle that they have a special relationship with. And the relationship is that they are the same number, the same length. Now, if I don't want to use the word matching, I could use the word corresponding. And that's the word that the books will most often use. You're used to doing corresponding angles inside parallel lines. Here's two parallel lines and a transversal. If I actually look at that side there and that side there, I've got my F shape. They are corresponding. They're also matching angles. They match up with each other because they are the same angle. But we don't want to be talking about corresponding in terms of parallel. We're talking about corresponding in terms of matching sides or matching angles. For example, if I go back to the diagram that I'd already drawn, if I go to this angle here, it will match up with that angle there. And I don't know what the angle is. Let's say, pretend it was 20 degrees. They're both 20 degrees. They match or they correspond with each other. And I could just as easily say that this one corresponds with this one, and this one corresponds with this one. Remember, congruent triangles will have three sides each triangle, and each side has a matching or a corresponding side that it has a special relationship with. Now, when we're talking about congruence, it's like an equal sign, but there's an extra part, and we don't ever use that for our equations when we're in Year 9. We don't say like x is exactly equal to 5. That doesn't make sense. But we do use that symbol when we're talking about comparing shapes. And in this case, we're dealing with triangles, so we're comparing triangles. So I could say triangle A is exactly the same, identical to triangle B. I don't say the triangles are equal. I say the triangles are congruent. That means they are identical. So, let's have a look. Now this is where it gets really important. This section here is really important to understand the labeling. Now, if we look at our two triangles here, I've got one triangle called triangle ABC. The other one's called triangle PQR. If I look at both of those triangles, on the triangle it's got A to B, it's got one dash on the side. On the triangle with R to Q or Q to R, it's got one dash on the side. Those two sides are the same length, which means they match each other. They correspond because they are the same length. That means A to B and Q to R are the same length as each other. Now, because I went A to B, you'll notice that near the A I've got the angle with the little circle, and near the B I've got the angle with the little square. Well, if I start with the letter A, when I'm talking about which sides match up, the side going from A to B, that means I've started with the A, it's next to the little circle, through to next to the little square on AB. That means when I look for its matching side, I need to go Q to R, because Q is next to the little circle and R is next to the little square. So I need to start and finish next to an angle that matches with itself. So that angle matches with that angle. So I need to start with the A on one of them and the Q on the other. I could have gone BA equals RQ. That's okay. So there is one pair of matching or corresponding sides. Well, let's look at the side lengths here with the 2 dashes. Or actually, we'll do the 3 dashes first. Let's look at the side lengths with the 3 dashes. I've got B to C and R to P. Let's go B to C. B to C, B starts next to the little square. R to P, R starts next to the little square. Good, B to C and R to P. They are matching or corresponding sides. Notice I'm using equal signs. I'm not using the congruent sign. I'm using equal signs. I'll show you where to use the congruent side later. Now the side that I haven't looked at is the side with the 2 dashes. If I go A to C, A starts with a little dot. So I don't go P to Q, I have to go Q to P because Q starts with a little dot. Now if you actually labelled them with the wrong order, I'm not going to get too upset. You've still got the right lengths equal to each other, but it's really important for more advanced work to know how to label them with the correct order, because it's possible to actually answer questions without even seeing the diagram if you understand how the labelling works. Well, let's looked at the matching or the corresponding sides when I compare these 2 triangles. If I look in this triangle here and this triangle here, each triangle has an angle that's marked with the little circle. So the angle at A and the angle at Q are the same. Now technically, the angle at A I might call angle CAB, and I'd say that's equal to angle PQR. But for the purposes of this exercise, I'm very happy for you to just shortcut the angles with the AB with just the letter that we're dealing with. So the circles are equal to each other. Let's look at the angles with the little squares. There's an angle with a little square next to the B, an angle with a little square next to the R. So angle B and angle R are equal to each other. And the little cross and the little cross, C and P, they're next to. So the angle next to C and the angle next to P, they are also the same as each other. Which means I've now matched up every side and every angle to its corresponding or matching side from one triangle to the other. This is where we use the symbol. Now we also need to take care of the order. I can say triangle ABC is congruent to triangle QRP. Notice the A is the angle with the dot. So I need to start with the angle that has a little dot next to it, which is Q. So A has to be first and Q has to be first. If I go after the A, I use the letter B. B has the square, come up to this triangle, R has the square, so B is second and R is second. C has the cross, P has the cross. C is last, P is last. So the positioning of the letters tells you that angle A and angle Q match. Angle B and angle R match. Angle C and angle P match. If you understand how it works, it's really easy. You could also look at the first 2 letters and say the side length from A to B and the side length from Q to R match. You could look at the side length from B to C and the side length from R to P match because of their positioning. And you could also go the side length from A to C matches with the side length from Q to P. There's a match. So really, if I have that written down, I don't need any of that information there. I know all of that information if I know how to read my congruence statement. Obviously I want it all because it's there and it's easier to see, but I don't need it all. I could actually generate it. Now, when we're trying to show or prove whether triangles are congruent, there are 4 different tests that we can use. So here are the 4 tests summarized on a table. The first test here, if all 3 sides in a triangle have an equal length to the corresponding side, so this side matches with that side, the side with the 2 matches with the side with the 2 dash, side with the 3 matches with the side with the 3 dash, we'd say side, 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 because each pair of sides match up perfectly. If we know that's true, and we can only know that's true if they give us the side lengths or they put the little dashes there. Notice this triangle doesn't have a dash on this side and this side. We can't say they're equal to each other. Not yet anyhow. So if we have 3 pairs of matching sides or congruent sides, that's one test to show that the 2 triangles are congruent. Now I'm going to look at the second test. I have 2 corresponding sides and the angle, the included angle. That's important, that word included. The included angle between them. So here's a side, here's a side, here's a side, here's a side. When I look at those 2 sides there, they meet and create the angle where the dot is. When I look at these 2 sides here, they meet and they create the dot. So what you actually have is 2 pairs of sides that match up. This side matches or corresponds with this one. That's the S. This side matches or corresponds with this one. That's the second S. The A is the angle that's included between those 2 sides. So between the 2 sides is an angle. SAS is the way we write it. The third test, 2 corresponding angles and a pair of corresponding sides are equal. So you have an angle and an angle that matches. That's your A. You have a second angle that matches with a second angle. That's another A. And you have a side length that matches there. And it doesn't matter which side length. It doesn't have to be the one where the 2 angles are on. It could be any side length as long as they match with each other and they're in the right position. Like I can't have a dash there and a dash there because this dash has 1 dot and 2 dots. This one has 1 dot and nothing. So you've got to be careful that they position correctly. The last test, you've got a right angle triangle, you know the hypotenuse, you know one other side, and you know that there is a right angle there. So you've got a right angle, they match up, that's your R, the right angle is in the triangle, they're both right angle triangles. H, they both have a hypotenuse that match up. And S, they both have another side that matches up. Why does RHS actually work? Well, it works because if it's a right angle triangle and this side match up and this side matches up, those sides must match up because Pythagoras' theorem works, which means that there you could actually go and use Pythagoras' theorem and you'd end up with SSS. Now, every time we actually show that things are congruent, we have to show it according to one of these 4 tests. In the next exercise, we're going to get more specific. For this exercise, I'm just really interested in you telling me which of the 4 tests can you use to prove 2 triangles are identical or congruent. Need to be careful. Sometimes I accidentally say sides are congruent and angles are congruent. They match or they're equal length. We're talking congruent, we're talking about the shapes are congruent. So let's have a look at our first example. Are the following triangles congruent? Are they identical? If they are, what test would you use to prove they are congruent? Well, let's have a look. Well, they might be congruent because I can see 5, 5, 6, 6, 8, 8. I don't need to know the angles. I know that those 2 sides match up with each other. The 8 and the 8 matches with each other. And I know that the 6 and the 6 matches with each other. So yes, these triangles are congruent. And how do I know they're congruent? I know they're congruent because they have 3 pairs of sides that match. They are congruent by SSS. That's the rule that we're going to use to show they are congruent. That's the test we would use. Now, it's important for you to understand in this exercise, I'm just asking you to spot which test would you use to show they're congruent? When the work gets more challenging, you actually have to prove they're congruent and match sides up. Now this is not I don't want to do it for this question, but it's not one of the harder questions. You'll see what they are later on. Let's go to the second example, or part B of the first example. Are the following triangles congruent? Are they identical? If they are, what test would you use? Well, let's double check. I've got a 4.7 metre side and I have a 4.7 metre side. I have a 2.3 metre side. I have a 2.3 metre side. Between the 4.7 and the 2.3 metres, there's 110 degrees. Between the 4.7 and the 2.3 metres, there's 110 degrees. Yes, these actually match up because I have two sides that come in matching or corresponding pairs, and I have an angle that's between them. So, yes, they're congruent. Why are they congruent? They're congruent because I've used SAS, side angle side, to show that they are congruent. They have a pair of matching sides. They have a pair of matching angles that's included between the two pairs of matching sides, and there's my second pair of matching sides. Let's go to look at part C. Are the following triangles congruent? If they are, what test would you use to prove they are congruent? So are the following triangles congruent? Well, let's check. They both have a right angle symbol. They both have 6 centimetres. They both have a 54 degree. So you might think they're congruent, but let's just double check something here. When I look at this, something's not right. If you look at this side here, that's the hypotenuse, and that's 6 centimetres. So when you look at the second triangle, the triangle RST on the right, this is the hypotenuse. Now the hypotenuse is the longest side. If both triangles are identical, their hypotenuses must be the same. So this must be 6 centimetres, not this one. Otherwise, the triangles can't be congruent. So when I look at this one, no, they are not congruent. Don't be deceived by going, oh yes, I've got two sides that match and two angles that match and things like that. You've got to make sure that they're in the correct positions when they match. We go to part D. Are these triangles identical or congruent? Well, let's have a look. 49 degree angle, 49 degree angle. So those two, the Q, angle at Q and the angle at U match. The angle at R and the angle at T are both 52 degrees. They match. So I've got two pairs of matching angles. And I've got a side, 8 and 8, and that lies, this 8 centimetre has the 49 and 52 degree angle on it. This 8 centimetre has the 49 and 52. It doesn't matter about their order because you can just turn the triangle upside down. So yes, these triangles are congruent because they have two angles and a side that matches or correspond from one triangle across to the other. Righto. We've got four triangles here. Which of the two triangles are congruent and why? Well, let's just go check now. First of all, I'm going to look at triangle 1. I've got a 5 and a 7 and there's an X between them. Triangle 2. I've got a 5 and a 7 and there's a dot between them, so they don't match up. Triangle 3. There's a 5 and a 7 and an X between them, so it might match with 1. Triangle 4, there's a 5 and a 7 and an X between them. So what I've done is I've seen that for all four triangles, every triangle has a side of 5 and 7, and the first, the third and the fourth, when I look at the 5 and the 7, have a little X on the angle between them. Now I need to look for more information. When I continue looking at my triangle, let's go to triangle 1. The side from B through to C is the side that goes from the angle with the cross to, I'll call that an arc. Cross to the arc has 7. Let's come to triangle 3. Cross to the arc has a 5. Well, they don't match up. Let's go to triangle 4. Cross to the arc has a 7. So what I'm saying is, those two triangles there appear to match up. Let's just double check it now. I know all three triangles all three sides, all three angles are given. When I look at it, for triangle 1, the side with the 5 has a dot and a cross. For triangle 4, the side with the 5 has a dot and a cross. So their angles match the side. With the 7, I have a cross and an arc for my angles. With the 7, I have a cross and an arc for my angles. Yep, definitely triangle 1 and triangle 4 match up. So what rule did I use? Oh, I could have got away by using angle, angle, side. I could have used side, angle, side, although I'd have to be careful because that might have actually accidentally given me this one. So I've got to do a lot more testing there. But when you carefully test it, you can find out which triangles are identical or congruent. So, example 3. Show the following pairs of triangles are congruent. Now, I have 2 angles in each triangle. Well, if you know 2 angles in a triangle, what do the 3 angles inside a triangle always add up to? They always add up to 180 degrees, don't they? So if I do 96 plus 41, if I add them up, they add up to 137. If I take that off 180, I get 43. If I look at this 96 and 43, and I add them up, they add up to 139. Take 139 away from 180, and there's a 41. Now, I didn't show the working out for how I got those missing angles. I'm not worried about that for this exercise. I'm worried about showing whether the triangles are congruent. Now, how do I know these triangles are congruent now? There's a 41 degree angle and a 41 degree angle, a 96 degree angle, a 96 degree angle, 43 degree angle, 43 degree angle. The side that has the 20 has the 41 and the 43 degree angle next to it. The side that has the 20 has the 41 and the 43 degree angle next to it. So I can say they do match up, and I can use 2 angles and a side that match up in the correct positions with each other. Which 2 angles do you use? You can use 96 and 96, 41 and 41. Or you could have used 96 and 96, 43 and 43. Or you could have used 41 and 41, 43 and 43. Doesn't matter as long as you have a pair of angles that match nicely with each other in the correct position, the triangles are congruent. And I'm just going to introduce the concept that we're going to be showing in the next exercise in more detail. If these triangles are congruent by angle, angle, side, that A stands for angle. Well, tell me 2 angles that do match up. Well, if I chose angle A, and I could choose any of these 3 angles, if I chose angle A, it matches up with angle Q. So I say angle A and angle Q are equal, they're both equal to 41 degrees. So that's saying they're equal. That's the reason they're equal. They're both 41 because I can see it there. The second A means I need to find a second pair of angles that match up. Now I'm going to choose the C. C is 43 and R is 43, which means angle C and angle R are both 43. How do I know they're both 43? I can see it on the diagram. I actually found them, and we'll talk about that later, but that's the process. Now I didn't use the 96 degree angle. I could have said angle B equals angle P and put that in place of either of these 2. The S means the side going from A to C and the side going from Q to R are both equal to 20 centimetres, and that all matches up. So that's the triangles are congruent by angle, angle, side. Not too worried about that in this concept in this exercise. We're going to spend more time talking about this in the next exercise. Although example 4 is a little bit different. It's not asking you to spot. It says, find the value of the pronumerals in the following congruent triangles. It's telling you they are congruent, which means every side has a matching side from one triangle to the other. Every angle has a matching angle from one triangle to the other. So if I was to go and look at this particular question here, I know because the triangles are congruent, the angle at B is equal to the angle at R. Now how did I know that? Well, let's just have a look at this. The angle at B is created by the side with 1 dash and the side with 3 dashes meeting. The side with 1 dash and the side with 3 dashes meet there. So the angle at B and the angle at R match with each other. And if they match with each other, that means 33 degrees and A are the same, so A equals 33 degrees. I also know that AB is equal to QR. How do I know that? A to B has 1 mark on it. Q to R has 1 dash or 1 mark on it, which means 5 centimetres equals N. So N is 5. Now, I also know, because each of these triangles are the same, there's 3 angles, and they have to have the 3 same angles in them, they'll add up to 180. So if I went to, say, the triangle on the right, I could have chosen the one on the left, I chose the one on the right. If I choose the one on the right, the angle at Q plus A plus 28 degrees has to add to 180 degrees. Why do I know that? Because the angle sum of a triangle is 180 degrees. I'm going to minus 28 to both sides. Oh, hang on, before I do that, I know what A is. A is 33. 33 plus 28 is 61. Let's now minus 61 to both sides. 180 take 61 is 119. If the angle at Q is 119, then what does it match up with on the other triangle? Well, the angle at Q comes from the side with 1 dash and 2 dashes. 1 dash, 2 dashes. Angle at Q matches up with the angle at A. So I can say, because angle at Q and angle at A match up, M has to be 119 degrees. Time for you to do some questions. See how you go on this more challenging concept. Bye for now.